Today we are going to work on square root functions. We're going to go over the parent function, transformations, and domain and range. So first we're going to start off with the square root parent function. Our equation is the f of x equals to the square root of x. I want you to notice that it starts on 0, 0. So that's your starting point. And your domain is going to go from 0 to infinity. Your range is also going to be 0 to infinity, including the 0. So we're going to write it in the three different notations. So in interval notation, we're just going to look at the bracket for 0 since it's on 0, and for the range as well. Now in equality, x is greater than or equal to 0, and set builder is very similar. And the same thing with the range, but we use y instead of x. So make sure you write these down, okay? So first we're going to start looking at these transformations, and we have 4 letters, A, B, C, and D. Each one does something very different. If the number is in front of your square root or in front of your function, so this is in equation form, this is in function notation. So function notation has that f of x, but the letters still do the same thing. If it's in front, like you see here, this is going to cause vertical stretch or vertical compression. So A is always vertical. If the absolute value is greater than 1, right here, it's a stretch. So this is a vertical stretch with a reflection over the x-axis. And this would be a vertical compression since the number is less than 1. Horizontal would have to be underneath your radical or inside your parentheses in front of x. Now I know up here we have double parentheses. You only need that if you have a b and c in the same problem. So this 4 right here is a b value. So my b is 4, but b is a little bit tricky. B, you have to take the reciprocal of it. You have to flip it upside down. So this right here is a horizontal compression of 1/5 with a reflection over the y-axis. This right here is a horizontal compression by 1/4, okay? Then we get into the horizontal translation and vertical translation. Notice that the c value is either underneath the radical or it's inside of the parentheses. And c is going to move it left and right. Now, because you see a negative sign here, we're always going to change the sign of whatever we see. So if we see a positive 6, this graph is really going to the left 6 because it changes. If we see a -4, this graph is going to the right 4. Now, what about if it's outside? So notice this D is not under the radical or it's not in the parentheses. And I've seen the D also, some will put it in the front. Notice that it's plus or minus from the equation. This is your vertical translation that's going to shift the graph either up or down. But it does exactly what you see. This graph is going to go up 2 and this one's going to go down 5. So now we're going to put these into the same equation. So let's look at these and let's describe our transformations. So again, we have 4 letters. I see this one has an A value because it's in front. And then I see that that 3 is really going to be a C. And we're going to change our signs, okay? So A is a 2. So let's talk about that. That's going to be a vertical stretch of 2. And then your C value is not a positive 3. Your C value is actually a -3, so this graph is going to the left 3. So we're going to move that initial point that started here on 0, and this graph went to the left 3. So my first dot I'm going to put is actually left 3. And so then I'm going to plug in some values. If I plug in a -2 here, because of that vertical stretch of 2, this graph is going to go up 2, okay? And so here is an example of my graph. Now, they're not exact points, but I'm going to tell you that that A value does not change your domain and range unless it's a negative. Why would a negative matter? Because it's going to flip it upside down, which would affect your range, but not your domain. Okay, so your A value made it stretch, but it did not affect your domain or range since it was positive. So my domain is now -3 to infinity. See, that left 3 affected your domain. And the range is still 0 to infinity because the graph did not go up and down at all. So go ahead and pause this video and try practice number 1 on your own. Okay, let's see how you did there. So this graph has a vertical stretch of 3, and the graph is going to go to the right 1. So this initial piece went to the right 1 with a vertical stretch of 3. So notice that this C value is going to affect your domain, and your D value will affect your range right here up and down, but this did not change. So again, if the graph does flip upside down, don't forget that does affect your range because it wouldn't go from 0 to infinity. Well, let's go ahead and give another example. So this has different values in here. So on this one, I see a B value of 3. And if the B is 3, this is a horizontal compression, and you need to take the reciprocal of it. It's a horizontal compression of 1/3. And then your D value, and the reason we know it's a D value is because it's the number that's not underneath your radical. Your D value is a -3, so the graph is going down 3. So to plot it, I take my first point and go down 3. And this is going to have the horizontal compression of 3. Then I plugged in a 3 value to get 0. Now remember that a horizontal compression looks similar to a vertical stretch, okay? So let's talk about domain and range of this graph. Let's look at the x value. The domain is 0 to infinity because the graph did not move left or right, but the range did go down, and the range went down to -3, and the range is going to go up to infinity. Go ahead and pause this video and try practice number 2 on your own. Okay, let's look at what you did so far. So this was a B value. So B was 4, but it had a horizontal compression of 1/4 because you take the reciprocal of it. Okay, and your D was a -5, so this graph was going down 5. So the graph went down 5, and it had a horizontal compression, which looks similar to a vertical stretch. I just plugged in a 4 here and found 4, -1 as a point, so I could graph it kind of accurately. So look, my domain did not change from the parent function, but my range did go down 5, so my range was -5 to infinity. Okay, so we have 3 more practice questions to end this lesson. I want you to go ahead and start with practice number 3. Go ahead and pause this video here and try this one on your own. We're just going to label the transformations. Okay, let's test how you did. This was an A value since it's in front of the radical. So this is a vertical compression of 1/2. Now this -3 is not inside the radical, it's outside. So this is your D value, and it's going down 3. So go ahead and try practice number 4 on your own. Pause it here. Hopefully you guys got this one right. This one only had a C value, but you always change the sign of C, so this graph is going to the left 5. Okay, and our last practice question, go ahead and give practice number 5 a try. Okay, check your last question. This -2 here meant that it had a vertical stretch of 2, and it reflected over the x-axis since it was negative. And this +1 here meant that this graph went up 1. So hopefully this video helped you practice doing some transformations and then how that affects your domain and range.